Okay, I think we're going to go ahead and get started. I'd first like to say that we do have several people
in on the webinar, and we'd like to thank IDS for sponsoring the webinars for us. Today I'd like to welcome our speaker, Lloyd Huff. He has been here as far as I know from the beginning of CCOM, and he has over 37 years in private industry and federal government. He got his doctorate in ocean engineering in 1976 from the University of Rhode Island. He worked at the Center for the Office of the Coast Survey and was chief of hydrographic technology program from 1988 to 1999. And he actually just came to us and was like, "Can I give a seminar?" He's actually leaving. We're sad to see him go, but glad he came to us. So moving on to other things. So with that, I'll turn it over.
It's wired up there. Well, the thing of it is that in general, I may overdrive it.
I can't believe that's true.
Yeah. No. If anything, that's the one thing that I do have is I tend to talk loud enough to project. Is that now good enough to go? What I would like to talk about today is actually it's a two-part survey. The primary work I'm talking about was done last year in Morocco, and then as we get all the way to the end, the final slide said we had so much fun doing the primary bit of work that we went back and did another month's worth of survey this year. And the group of Yuri just said he challenged me to pronounce all the names correctly, and I'll just paraphrase. It's Lloyd Huff and Mum. Our picture, sort of a little inset on the side over there, is the motley crew that we work primarily in Larache.
Put the cursor in the screen that you're trying to and click on it.
Is that one good?
Put it on the other screen.
Yeah.
Put this. There you go.
Okay.
No.
That gave you time to already formulate these two questions, okay? Which I'm quite sure that you were both wondering about. I mean, why survey in the Loukkos River is very, you say there's a lot of rivers around here, why worry about the Loukkos River? And the other question that I'm sure that some of you, if not all of you, would also raise is why would you use an AUV to survey in the river? The first part of the question I will answer has to do with the archaeological implications of this survey. And Loukkos, those of you who you might go to Google Earth and look at Loukkos, and or if you are a Roman historian, you know that Loukkos was a very important city, and its product was fish paste. Now, I'll say sort of like little salmon paste or other sort of thing that you might have. And that you notice over here the amphora. And again, most people's knee-jerk reaction is amphora. Well, that's what wine, raisins, figs, and oil was shipped in. But actually, one of the most valuable products that were shipped in amphorae was fish paste. It was a high-protein food supplement that was provided to the Roman army. So that you've got this Roman facility in which that they didn't make amphora locally. They're shipping amphora in, and they're also shipping out a large amount of this fish paste. In the meantime, they've got local fish and got local salt. So the point is that there had to have been some sort of major port facility in order to take care of this material transfer. but there's never been one's never been found. The port's never been found. And as part of UNESCO's push to get countries to get a better understanding of their cultural heritage, and particularly their maritime heritage, that ports is a significant feature of somebody's heritage. And that not only is this site important, but there right now that in the Larache area, there's a large number of changes going on in the modern infrastructure. And I'll talk about that, show those in a minute. There was also that two of the students that we worked with, and the group we worked with from Morocco was from Mohammed V University in Rabat. But two of the people were PhD students, and there was a professor. So there was an interest in looking at the Loukkos River Basin, trying to look for previous channeling, because as, again, two things that come up often. One is tsunamis, because there's money in it, but there actually have been tsunamis in the area, and there's clear indications of the events associated with the Lisbon earthquake. And the other one is that from a climatological change, people say, well, it was a freshwater lagoon, and other people said, no, it's always been a marine location. So the idea here is to be able to look to see where the river basin may have been over time, to try to help get an idea. That doesn't tell you exactly what was happening in the basin, but it gives you an indication of where you might be able to look for evidence that would indicate whether it was a freshwater marsh or what. One of the studies also was one of the things was also to support bed forms studies, and there was particularly interested in determining the upstream point where the primary influence of the bed form shifted from being on flood to ebb. And I've just shown here a nice little stair step or sawtooth set of waves. And when we're in close to the mouth, then obviously the orientation of these switch with ebb and flood. And as you get further upstream, there's a point to which they don't flip anymore, and that has some information that people want to infer about sediment transport in the basin. This modern infrastructure, there's roadworks right now that are going on, and these are impacting the estuary drainage, and they're also covering up archaeological material. Now you start changing the estuary drainage, and you're going to change a whole bunch of things in terms of the river dynamics, sediment, etc. There's also increased tourist activity, and that's what this little panel here is, in which there is now a modern port, Loukkos, which is a big hotel golf course complex that is being put in. And the other one, in the mouth of the river, fairly close to it, they're pulling like 6,000 cubic meters of sand out of the river every day, 24/7. And that tends to have a change impact on the sediment balance in the estuary. To give you an indication that this actually is a Phoenician grave, and it's only recently been examined. And over here is the hill of Loukkos, that is where the primary city was, and this is the bend in the river. But these are from 2nd, maybe 3rd century BC Phoenician. And so that, looks like that's very, somebody's been there very actively working. But you talk about having your back up against the wall, and on the other side of the view is here where they're trying to do a systematic investigation of 2,000-year-old, 3,000-year-old burial site. that you've got the backhoe digger and they're piling dirt right in there. So very soon this is going to be gone. And in the process of doing changes so rapidly that the archaeologists can't keep up, and there's a concern that since there's got to be a port somewhere, just hadn't found it yet, if you have enough time, resources to look for it. But that doesn't help you if it's buried under, as you say, the equivalent of 495 or something. And so there's a big impetus to try to get these studies done now in order to document, not that they expect to be able to stop progress, but at least to have a better understanding of the impact. Why do it with an AUV? Here's a list of things, and some of those that you may or may not appreciate. Essentially, easier daily mobilization. As an editorial comment, I think that too many of our people think surveying is going onto a big boat, carrying on your laptop, and you sit down and you take numbers and process them. Well, when you're doing this daily, mobilizing daily on a small fishing boat, 7 meters long, can you imagine how much time you'd have to spend each day doing your patch test, doing the offsets and all these sort of things? Whereas in an AUV, all that's in the AUV. You just put it in and operate, and in that case, the patch test and all of the other offsets, they remain the same. But because of the security of the local port, we had to put this on and off every day. We spent 30 minutes mobbing and 30 minutes demobbing every day, and because we were using a local fishing boat. The other thing about an AUV is it circumvents line control issues. Yuri made the comment about, if you will, challenging me to pronounce those names. But can you imagine me trying to tell the captain of the boat, the fisherman who owns it, left, move over 5 meters, a little faster, a little slower? The lines of control were difficult because that my Arabic is a little skimpy, and that we actually in many cases went English to French to Arabic and back. So the issue about lines of command and control issues. The other thing about using an AUV is you got a limit. You're in a foreign location, remote location. You got a small number of people there to do work, and that with the AUV, that you then can launch the AUV. It'll go do its thing, and that frees up the small boat, the support boat, to do other functions during the same time. So that allows you to work a combination of parallel and serial. So CTDs, sediment samples, things like that, watercolor measurements, that can be done in parallel. The other thing is that you see that there's a whole bunch of different sizes of AUVs. Lots of times today when people think AUVs, it's the Huygen. That's what you kind of see most often, and it's the one that actually, I guess, does the most mileage of survey type work now. But there's a bunch of different AUVs. And the other thing is that by using the AUV, I can run the AUV into shallow water where I couldn't necessarily run my boat. So we have these, we've reduced the depth limitation that was imposed on operations by doing with an AUV. Now the combination of two of these things, the fact that the AUV goes out and does its thing, will run repeatedly, very carefully, the same line every time, and this concern about going into shoal water, essentially allows you to work, clearly not the hydrographic standards, but in order to be able to understand the potential orographic effects of the seabed on river bends, that you can do what I call the triple point sort of measurements using the side scan sonar. And just to give you what I mean, because we started doing this with the Klein 5000 in 1993 or something, and it was also been used in 2002 using a Dr. Aaron Holtz system in Germany, in which case that the typical little side scan image here, we have the AUV, and then in that case, we get the first bottom return stuff here. We get a signal from that upslope, and then you see at this point, there's what's called the triple point air water bottom. If you had gone over here in the high water case, that you still have the same sort of thing over here. It's a bit further to the first bottom return, upslope, second upslope even, and then you get the triple point. So if you do this at a series of stages of the tide, that allows you to build slices, horizontal slices, of the DEM actually in the surveying itself. And here's an example. There actually is a little red line going right down there, okay? And that is the triple point in the air-water bottom interface. And when the stage of the tide changes, essentially this will move back and forth based essentially on whatever the progressive slope of seabed is, and then you don't have as much likelihood of running yourself aground. Let's see, we said this. Darn. Why did we say we were going to do that? Okay. The other thing about AUVs, little AUVs anyway, is they're kind of handy to put in. You don't need a big winch and everything like this. This is an AUV. Actually, one we used here in Great Bay. And then it waits for just a few seconds or something like that, and it says okay, and it'll come back up to the surface and rev up its engine and take off. In the meantime, you can go do whatever you want to do. Just pictures in Fall River. That's not Morocco. However, it's not a slam dunk surveying in a river with an AUV, because that those of you who understand that and when you have a bend in the river, that this area in here tends to be depositional, and it's erosional on the other bank because of the acceleration of the flow stream in the process of going around the bank. Well, if we're running chevrons, you know what a chevron is? Okay. It's like a big M, okay? You're running chevrons across here, that means that you're cutting perpendicular to the currents all the time. And so that's one of the things you have to be careful about when you're planning the mission. And just to show you that this area has changed, is a dynamic at some scale, that these vegetation lines you see there, okay, that was a prior epoch in the bend of this river. And depositional, it's moving this way, and at the same time, I say largely, it's eroding on this side up until it gets to the edge of the steep slope, and then that you got to start doing something else, because you can't just keep doing that forever. The other challenge that you have is proper weight and trim. And when we're going up the river, you see a situation. This is upriver distance from the mouth or at the jetty, and you see on 2 different days when we made that run that the salinity, of course up here we're close to 33, 35 open ocean seawater, Atlantic, and then as we get upstream, okay, that it's dropped considerably. Well, that much, change in salinity causes a fairly large change in density. And so if you want, it's not just density in terms of getting the thing to go up and down, but also that the issue of what the trim is, because you want to be able to be surveying starting out with your AUV horizontal trim statically, so that the dive planes then are working in their maximum advantage. And so that not only does it change on space, but it changed on in time 2 different days. Sorry. Well, we didn't just say, gee, let's go over there. We did plan ahead. We went through a series of tests, and that in terms of the selection of the equipment, we tested the equipment, we reviewed what boats were available in Larache, what kind of fishing boats were available. We looked at prior survey data, a little skimpy, but we did the due diligence to check it. We did our survey planning, we did mission planning, and then that we developed a scheme to have the maximum potential use of the data, because this river has not been surveyed ever systematically. And so that means that everything you find is something new that somebody may have inferred, but here it's not an inference. You're getting actual data to be able to substantiate it. So truly in the sense of OCS's policy of, survey once and use many times, we were doing that. We were doing that in spades, okay, in this case. Just a little bit about showing systems tested. We tested them all in Great Bay before we went, and this, courtesy of Shahak, is the eelgrass and algae. And here is the Ivor track. Actually, that day we ran 3 Ivors in consort. We organized them so that we could run 3 of them in parallel. Here's the rock, which is probably the only big rock out there, as long as you don't count Nanny Island as a rock. But here you notice that clearly that this gives an indication that the data potentially contain information related to the environment. Don't want to push it much further than that, because you don't really right now know exactly what it means, but clearly that the system was functioning, and there appeared to be some sort of not necessarily linear response, but just a change in response based on the environment. And we have our own opinions about what in the environment causes things and what it means when it does change. This is actually from a picture from this year. We did another set, but this one was prettier than last year's, in which that we were looking at the sub-bottom profile just to be sure that the Knudsen 320M was in fact working correctly, because if we had any hope of finding these old I'm walking on my microphone, and you probably never even noticed. Okay. Anyway, so this shows that that system worked, and we went through a series of other tests. Here's our prior surveys. That right here is a little survey that was done prior to starting the dredging, and the dredger sits right there, sucking in sand and pumping it on the shore here at a fairly hefty pump. The older survey was done in about 1960, and then you see the satellite imagery. You can see a few things in which that the large-scale topography has stayed the same. Here, even these little riverlets, okay, match up spatially after 40 years, but you can also see a significant erosion right in this area here. And this little point right here is called the White Cliff, and that's where those Phoenician graves were. Because that if you were to go into the harbor, up the stream, that the thing that would be right in your face is sort of like going to the cliffs of Dover. It's clay, white clay, and it's very, very pronounced. And you can imagine that that would have been considered an impressive place by the Phoenicians 3,000 years ago, sailing up the river. But as I said before, the river can only go so far eroding in that direction because this clay cliff here is a serious impediment. A few photographs to show you what the experience was. We're on this boat, okay? We'd never been on a boat. I just told how big it was. Had a picture of it. So we prefabbed the survey control center and shipped it over. And here we are assembling it. This happens to be Hasna. This is Eunice, the captain, and that's myself. And again, over here, we had a gas-powered generator that was running it, and the other fishermen were asking Eunice, our captain, are these guys crazy? I mean, they're hanging their gas-powered generator in a sling. I mean, why would you do that? I'll tell you why. 10 dB less noise in the sub-bottom profiler, because it wasn't sitting there right on the bottom of the boat, banging out sound. But little things like that they thought we were a little over the top. I guess that after we were outfitted, we did look kind of a little bit over the top. Okay? You see the sub-bottom profiler over the side. This is, no offense, we call this the Pope boat. The Pope mobile that he rides around in, we call this thing here the Pope boat. But by George, it worked. Yeah? And we had some torrential downpour inside, bone dry. When we were there, we had to test the AUV for balance and trim. And in this case, we went to a cove, and here, under using wireless commands, we were just giving the Ivor a little run around and checking its ballast and everything. This is Ollie, one of the PhD students. But I didn't. I guess I wouldn't have got in real bad trouble if I had lost the Ivor, but I thought it would have been bad form. So that being sort of a conservative person, we started out with an approach of not quite walk the dog, but we didn't want it to go too far. I'd hate to have to go out onto the mud bank trying to recover it. So we ran it loosely coupled, and then eventually we ran it without any manual intervention and let it go by itself. But we were quite pleased when we were able with ourselves. And to Brian, we were chuffed. We were quite chuffed when we were able to get that thing to go. And this one, you notice that blue one is the same blue one you saw thrown in the river at here's our sort of mission planning, in which that Loukkos is this facility place right in here. These are salt pans where they still evaporate salt and have a production. So these are the positions that we plan, and each one of those has a little function, whether you're parking or diving or sensing data or some other sort of thing.
What's the scale of that now?
From this right here, that's 60 meters. The width of this swath, of one of the swaths, is 60 meters. And I think I have another slide that addresses that issue, but that is an important point. That's a simple one. We did some complex ones as well, in which I think there's 75 individual segments in here, in which that we ran with both the wide scale, wide range, and short range, And this area right here is the white cliff that I keep referring to. The our coverage within the Loukkos River was actually all of this purple area, and that in this little circle or ellipsoid in here, that's where not only could you see bed forms, sand waves, bed forms in the satellite photography, that you could see them very clearly in the side scan. And this is just an observation of that of those bed forms. And this was we cropped it at 60 degrees alternator. And these are the ones that we were studying, because we went back and forth across this area many times at different stages of the tide, trying to be able to capture when the sense of the waves flip. This is a situation, again, the white cliff you've heard me call out. This Salinas corner is the place where those salt pans were. And this is a long scan, but right in here is where that we've seen some significant structures. And when at exceptionally low tide, we were able to go down and see that there's this primitive working in the bedrock here. And that's 3 feet. So this is a likely point. People argue that the fort was on this side of Lixus. Other people say it was on this side of Lixus. Probably was both, because at different time, they were there for 3,000 years. So at different times with the meandering of the river, that they're not going to go trucking this stuff out across the mud flat a long time if on the other side of the hill that the river has come in real close to you. One of the things that we did, remember I said maximum utilization of the data? What I was referring to here was the vertical beam echo sounder in this case was only pinging once a second. The side scan was pinging anywhere between 8 and 13 times a second. So in terms of delineating the long track definition of bed forms, clearly the side scan sonar gives you better spatial resolution. Now if you think about what side scan sonar is or does and how the information is extracted, that when you make a mosaic, the first thing you do is you find out where was the first return, meaning the altitude, and you use that parameter in the mapping to flat Earth. Well, what is that bit of information besides altitude for working out the side scan sonar? It's also the depth of the bottom. And in this particular instance, since the long track width of the fan beam is essentially the same as the cross track and long track of the vertical beam echo sounder, that you actually then can increase the number of hits, if you will, on the target, if you like. But just to be sure that they really work the same, we did a comparison between the vertical beam depth just before a side scan, and then took the next side scan that came along. And in the comparison, there's a very good comparison with about 11 centimeter uncertainty. Well, 11 centimeter RMS. However, that's not all uncertainty, because remember, I'm taking the difference between two random signals. Each one has a contribution to it, and decide, depending on how you want to partition it between those two. But nevertheless, at 11 centimeters, we said, nah, they're the same. Don't have to worry. And so that actually, using the side scan sonar and the vertical beam echo sounder, that we built a very detailed DEM of this is the White Cliff corner, and much as you might expect, that on the outside bound of the river, it's quite deep. It goes down to like essentially 18 meters at low water, which is a significant difference compared to the other sort of depths around the area. And we were able to do this level of presentation because that the side scan sonar augmented by a factor of 8 to 12, 18, the soundings that we had. One of the things that we did, not just for grins, but when you're trying to study water quality, that one of the simplest measurements is, what does the water look like? And so close to the mouth of the river, we took pictures, and we were always careful to take them so the sun glint was away from us. And this was, what we were trying to do was define the point of maximum turbidity. If anybody studies rivers and estuaries, we were looking to see where the point of maximum turbidity, which has to do with the chemical interaction of the clay particles coming down the river, and when they are in fresh water, that I could do. When they were in fresh water, when they're fresh water, essentially that keeps the ionic thing, just keeps all the particles separated. As soon as you get down to the salt water, effectively that shorts out all those free electrons, and then you develop flocculants, okay? And right then is the point where you tend to have the maximum turbidity in a river, because as you go further to the mouth of the river, it's precipitating out, and as you go further upstream, they're free. I don't know, from my side, I can clearly see the difference, but you see at the mouth of the river, and then 5 kilometers upstream, and we have a whole succession of these as we went upstream. So I can say, as I did to start with, that our October 2009 AUV was a success, and that caused us to be interested in going back, and we went back in this year. We're even more successful this year than we were last year, because the AUV we ran this year had a little multi-beam on it, where before it was only a single beam and had a DVL. So I think that's the end of the slides. You always like to say finished on success. Any questions?
What's your navigation? You ran the AUV in the surface?
Well, remember a gentleman by the name of Samuel Clements, okay? And he had a task once of riding riverboats and taking soundings. And that if you read his writings about that, he always makes very careful mention of the fact that on every cruise, if you will, that there might be anywhere from 2 to 5 pilots, okay, riding, which they called it running the river, because that what they were doing is they were updating their mental picture of where the shoaling and everything like this was in the river. So that first off, you couldn't even trust, where's this thing going? You can't even trust a Moroccan chart, okay, because that first off, it's in French French truncated polyconic. So it's fine in the north-south dimension, but it's not so good in the east-west. So what we did was we actually ran the river, and we took and ran in order to find out where the river was and map it in WGS 84, because we weren't 100% sure that we could trust the Google Earth, which might be good to 25 meters. Well, remember, the river's only a couple times wider than that. And so we actually ran the river to define where the river was, and then we used that in our mission planning. And we always did it. We ran the low water line. Sure.
Do you have plans to put other instruments on an AUV, like the optics, to measure the ocean
photos? On the local camera?
I mean, it's done now. It's just that whether or not that what AUV you happen to use, and these were made by Ocean Server. I think that virtually any AUV that you're going to run today, unless it's one of these little 10-pound guys, is going to have sonar. It's going to have one, if not two, cameras, and several other things like this, iridium communication links. So it's just a matter. It's the Chinese menu. You know, what do you want to put onto it? You know, and you want to. You know, it's the thing about lots of times that you have to be careful because of IP and things like this. But the Ocean Server, and I'm not pushing Ocean Server. I'm just saying that's the way this one is. They got a front seat, back seat, and that they give everything that's in the back seat. They give you total control, total access. If you want to change anything, and you can put different sensor suites on. They give you the power, the hookup, things like that. So it's a matter of optimizing it for your particular mission. Having said that, I think that it's unusual. It really is a luxury for you to be able to plan a survey and say, okay, what I need is this. And then you go and buy it or whatnot. What you really do, 99% of the time, you say, this is what I need to do. This is what I've got in the warehouse. How do I make what's in the warehouse work as best I can for the mission I've got? So, you know, the issue, it gets kind of fuzzy sometimes between saying that you've planned to do something when if it wasn't on whether it's a boat or a sonar or something else. But yes, I think that there's a lot of use for color, the color measurements, color camera, and so in this case we were just taking them from the top. But any other questions?
Yeah.
Yes, Al, Bill?
All right, go ahead.
So we had a question from one of our remote listeners.
Yes.
Rod Evans from SAIC, and he was asking what primary positioning system did you use for the AUV? Or was it, the GPS uplink when it was at the surface? Or?
GPS. The system has a very fast acquisition, and it takes about a second and a half or something like that in order to reacquire. The underwater navigation is done with a combination of dead reckoning and DVL, and that when you come up, you get a fix. And that you saw those different waypoints that are in it looked like whatever is chicken mesh or something like that on the mission planning. Those were where we popped up purposely in order to be sure that we were maintaining our navigation control.
Well, did you operate through the salinity changes that you showed on that plot? We've been worried about operating from saltwater to freshwater, and your vehicle becomes heavier than if it started off neutrally buoyant and you end your mission and it sinks to the bottom and comes to the surface. Yes, we
went through those, and there's I won't say there's a trick to doing it, but usually conventional wisdom says you run your mission and then you park it and let it come to the surface. Well, what we did was you ran the mission and then we ran it full speed to make it get to the surface. Okay, while it was running full speed at the surface, we then would run and pick it up. And that was the way that I was able to keep it from sinking when that happened. But I'd just like to say one other thing about the line control. The Eunice was very, very nice, very, very dear guy. And of course he knew how to run his boat and all these sort of things. But two things that come to mind. One was we finally got to the point to say, okay, Eunice, go to that blue mosque. Okay? And so he heads to that blue mosque. One day he sees his fishing buddy over here. He just veers off, goes over, chats a bit, has a cigarette, and then from that point goes to the blue mosque. Because to him, blue moss was the objective. That's the way we defined it. And the concept of that I need information along that track line was something that was a bit difficult. And the other thing is, if you've ever worked with fishermen, they have their own way of doing things. Now, he got highly agitated with me, but we spent 2.5 hours one day practicing how to approach the Ivor when you had your security float back of that, the polypropylene. We did it. Finally, he got to where it'd be really good. And I said, okay, let's do it. So then what he does, he reverses his old way of doing it, but backing down until just before he gets the line in the prop, and then he grabs it. But we just practiced for 2.5 hours. And so these sort of habits, that's why I'm saying that a lot of things, that's why an AUV is so good. It does what it's told to do.
How do you manage with other boats?
You have to be careful about that, and that what we would do is it wasn't just the boats that you had to worry about, but fishing nets. Okay, and what we would do is lots of times we would run an area, check to be sure it was clear of fishing nets, with the intention of coming back and then letting it run. There's some fishermen putting a net behind us. You know, we just went by the area, and they're now out there putting the net in. So that's a problem. But we didn't run into anybody. And the thing about a small AUV is, if you just look at the flow field around the hull of a vessel, that if you're about to hit that vessel, the flow field, actually that current vector deflects the small one. If you had a large one, like a Huygen or something, okay, it doesn't stop. It hits, it smashes, you got a lot of momentum. So the advantage is that you don't have a lot of inertia and you're able to take advantages. But I tell you, I worried every time the thing went under. I thought, will it ever come back? Will it ever come back?
Could you run a full day on one charge of battery?
We could run about 6 hours, which was a full operating day for us.
Yeah.
Because remember, our mob and even.
Well, what was it you were? How did you hope to know that you might have found some remnant of the port, and in fact, do you think you did? What were you what in the side scan sonar record? What were you looking for?
Straight lines. Anytime you find a straight line, it's going to be a man-made object.
Or a log.
Almost always, it'll be a straight line. It'll be a man-made object. But we also did a terrestrial part of this, because every port has got terrestrial facilities as well, and so we did soil resistivity measurements along the bank of the river. And in doing that, we actually then were able, in this case, to this year, identify about 75 meters of a new wall, which nobody had ever known that it was there. And that then begins to look like, well, that might be the sort of thing that could be, part of a warehouse or some other sort of structure based on its orientation with the present river. But I'm assuming that the present river, which was close to the Loukkos, would have been there at the same time this was going. The other thing was we identified some new basins. Very early I showed basins. Have not yet been dug or worked on enough to find out whether they were production bases, storage basins, or for that matter, they could have been a hot tub. You don't know which. But there, it's just, I'm going to say, like, if you've got an operation, you don't mobilize your divers initially and carry all the divers and all the equipment. You go out and locate where you think the likely thing is, then you go back and focus the diving on that because of the safety and the cost associated with doing diving, especially, where you saw how small our boat was, so that we had to, it's a question of what you do in series and parallel. It just take, whatever it was, it'll take more investigation. But that's lots of times the way archaeology and surveying is. You don't get a definitive answer the first time. You develop some information, a hypothesis, then you test that hypothesis and build on it. It's a slow process. Yes, Brian?
Is there a process for protection of these artifacts should you find any?
Yes.
Is it an effective process?
No. It's that this is a problem. Well, I mean that in Scotland they're much more attuned to that. Scotland, England, France, they're a lot more attuned to making being careful about their prehistoric remnants, which are back at low stand of water. In this case, that it's still, that mindset is still developing, and it's sort of, I mean, it's understandable because that when civilization has got a lot of other things to worry about, or government's got a lot of other things to worry about, that unfortunately, if you will, cultural heritage tends to be kind of low on that list compared to being sure that everybody's getting fed. But there's always improvement. There definitely is an improvement, and in this case, that I've been working in Morocco now for 9 years, and that they finally this year have been able to get a new hydrographic survey vessel, which before they didn't have. And so what we've always been trying to do is develop a three-way arrangement where that the hydrographic surveys can be done in areas where the coastal change people are interested, and in turn where the marine archaeologists are interested in, to try to maximize the advantage. It's really slow in getting that sort of cooperation.
Is there any significant subsidence in that area that might have just taken everything that was there and, 100 BC and buried it 100 feet under the present seafloor? There's mixed evidence that clearly the Atlas Mountains, which is a fairly significant feature in there, there have been estimates made there about what the uplift and things have been. But in the area around Larache, it sort of appears to be in an area where there was rise to the north, rise and fall to the north, and into the south. But in this area of about 100 kilometers around Larache, that there's no indication that had gone on. There's a French team that studied, been in and doing vibrocores, and we actually coordinated our sub-bottom profiling in areas where that was nearby where they did their core. But the University of Mohammed V in Rabat is studying the issue of coastal change. There, and in this case, I'm relying on them to say, no, that's not an issue. Yes, Yuri?
We've been talking about Phoenicians and Romans. So the modern Moroccans, do they consider it as their heritage as well? Or it's something foreign for them, or which happened to be on their land? Do they care about it?
Morocco is in the early stages of lifting from being a tribal-based society to a kingdom, and therefore that there still are large regional differences between what people view as their cultural heritage based on their previous tribal associations. There's distinct improvement, though, in terms of, with the new king, of trying to unify the country. The previous king, for some reason, I forget the story now, I heard it 2 or 3 different ways, different times, was that he thought he had been snubbed by the people in the northern coast of Morocco, so he didn't put any money up there. The new king, who's been king now for half a dozen years, seems to be very even-handed in terms of putting money and infrastructure around the country. And that's gone a long way to cause the people to move away from tribal-minded to kingdom-minded. Political statement, but okay. Thanks for listening.